Welcome to Graphite Hub. Today we're here at CarbonScape's facility in Blenheim, New Zealand, a company turning wood chips into graphite. Follow along as we talk to Heinrich Badenhorst, Chief Technology Officer, on how this process actually works. How do you actually do this? How do you turn wood chips into graphite?
We have a thermocatalytic process that we use. So basically we take in the biomass, then we convert it into charcoal by pyrolyzing it. Then we add a catalyst, we mix those two together. We put it through a heating step in a RHK or a roller hearth kiln. And then that material is post-processed. So we remove the catalyst, purify it, shape it, and coat it.
Join me on a plant tour of their facility, where we walk through the full journey, from biochar arriving on site, through milling, graphitization, purification, spheronisation, coating, and finally, cell testing. CarbonScape's process is different from conventional synthetic graphite. Instead of starting with petroleum feedstocks and heating to around 3000 degrees, they use biomass and a catalyst, which allows them to graphitize at much lower temperatures. We'll kick things off at the point where the material first enters the facility. Starting with the biochar gives CarbonScape a consistent carbon backbone to work with. From here, everything is about controlling the catalyst and the downstream processing conditions to tune the final graphite. Once the biochar is on site, the first real processing step is to grind it down to the right particle size and distribution.
This is the, well, it used to be a rod mill, now it's a ball mill. And so that's how we process the biochar. So the charcoal then gets ground down to the size that we want and screened and filtered.
Once the biochar is combined with the catalyst, it enters the RHK, where the material will sit in saggers and is heated to around 1500 degrees. And as it moves through the RHK, it slowly transforms into graphite.
We actually did testing to prove our commercial scale facility is going to work. We did something called toll processing. So we toll processed at an RHK in Japan, and we produced the material, sent the material there, had it graphitized and then sent back. And so you can see the saggers, it's exactly the same saggers we use here, so we're sure of consistency. And so the material, as I mentioned, gets mixed and dried, and then it gets put in here. Yeah, there you go.
The next stage is purification, removing the catalyst and reducing impurities to battery-grade levels. In this step, the graphite precursor is combined with hydrochloric acid in a carefully controlled leaching process that dissolves the catalyst and washes out the remaining impurities, ensuring the carbon is properly prepared for the downstream stages that follow.
The downside is it's more complicated than the other two processes, right? For natural graphite, you grind it up, you clean it up, spherinize and coat. And for synthetic, you source the coke and the pitch. But for us, we do have several sort of steps in getting to the graphite. And like I said, that gives us flexibility, but it also adds complexity.
With purification complete, the material is now ready for spheronisation.
Process, it's called spheronisation. So one of the key factors in getting the graphite anode performance is you want to increase its tap density, which increases the energy density of the final battery. And so what we do here is we're essentially shaping the particles, because the most efficient packing that you can achieve is if it's spheres that pack. And so this is like smoothing and rounding the particles so that we can achieve the best possible energy density.
The next step is coating, one of the most important stages in producing anode material. CarbonScape applies a controlled carbon layer to each graphite particle, stabilizing the surface and improving the initial Coulombic efficiency. Coating reduces irreversible capacity loss, protects the particle during cycling, and helps form a more stable, solid electrolyte interface. Coated graphite is only half the story. The real test is how it performs inside actual cells, and this is the lab where it happens. The team prepares a slurry from the graphite powder, coats it onto copper foil, and assembles coin cells and small pouch cells to evaluate performance. Once coated, the foil becomes the anode, which is then paired with the lithium metal to measure capacity and first cycle efficiency. Testing begins with coin cells before moving on to pouch cells, and from there they scale into larger cell formats to confirm the material performs consistently at every level.
This is where we do all the powder, well, not all of it, but most of the powder analytics. So we have impurity analysis using X-ray fluorescence. We have particle size analysis using laser diffraction, and we have surface area using nitrogen absorption. We have some TGA to look at the carbon content of the charcoal, and we have X-ray diffraction to look at the quality of the graphite crystals.
And here we have tap density, a measure of how tightly graphite powder can pack. CarbonScape fill the cylinder with graphite, place it into the tap density machine, and let it tap a few thousand times. The change in volume shows how the powder settles, a key indicator of how densely an anode can be packed. And here we come to the final product storage area.
So we actually have a manufacturing execution system that we run called iMonitor. And so everything is bagged and tagged. So we have these QR codes on everything so that we can track at each step in the process, where is a batch at, when are we expecting it to come through the final stages. And we also link all the analytics to this, so everything is tracked in terms of how it was processed, what are the associated analytics, and then ultimately what are the final cell results for that. And so I think this is a key part for us of the whole QC process.
Thanks for joining us. We hope you enjoyed this behind the scenes tour of CarbonScape's facility in New Zealand, and we look forward to bringing you more high quality graphite content in the future.